All right, so 13D, we've got our zinc metal here, and we want to know if it will react with this solution. And so the sulfate ions are spectators, so we're dealing with the copper metal, the copper ions, okay, so we've got our metal solid and we've got our metal ions. Okay, so we need to locate these in our table and see if we get a reaction between them. So we've got zinc and we've got chloride 2+ as a oxidant there. Okay, so we're going to write them out exactly how we see them in the table. And we're going to circle the species that we have present in our experiment. We've got our zinc solid and we've got copper ions. And we have a downhill reaction here. So we are going to get a reaction which we need to write a formula for. So the copper 2+ is going to want to accept the ions, the electrons, and so will be reduced. And the zinc is going to want to go that way. So the top one always goes to the right, the bottom one always goes to the left. Okay, so let's pop our states in. Everything's pretty well balanced. Our electrons are the same value, so we can add our half equations together to get an overall equation. And the funny thing about this question is that it wants the spectator ions put back in. So we would be pretty happy with this unless we specified otherwise. Okay, so because it's asking for a fully balanced equation, we need to put the spectators back in, which is something that we will tell you if we expect you to do that. So the ions, positive ions, are going to associate with the negative ions of the sulfate. So how would they associate? Okay, so they're still in solution, bear that in mind. Now 2+ for the copper and SO4 2-. So ionic formula would be copper sulfate like that. So copper sulfate aqueous. The 2's cancel out. We've got our solid zinc. The copper is being reduced to the metal, and so our zinc is going to associate with our sulfate ions now. And we've got 2+ there, so 2, 2, so it's the same ratio, 1:1. So zinc sulfate there, and we've only got one zinc there, so that's all good. And so that is a fully balanced chemical equation if I pop an aqueous there.